question 5. So let's start off by labelling our diagram with all the angles that we're told. We're told that a ship is moving on a bearing of 25 degrees to start with. So remember, bearings are measured clockwise from north. So from point A clockwise, that's where we get that 25 degrees from. Secondly, we're told as it passes point A lighthouse L is seen on a bearing of 340. So bearings are measured clockwise, as I said. So there's the lighthouse as we pass point A. So we need to go 340 degrees clockwise, which is all the way around to here, which of course just leaves us with the remaining 20 degrees, because obviously angles about a point add up to 360. So that 20 degrees has come from that 340. We'll need it later, so let's just process this other bit of information. We're also told as the ship passes point B from the lighthouse, it is seen on a bearing of 320. So again, as we go past B, the lighthouse is on a bearing of 320. So measuring from clockwise all the way around to here is the 320, giving us the 40 degrees here. So that's where I've got those three angles here. Again, because we'll need it later, I think we might as well just fill in these other angles. So this pink angle here has come from angles on a straight line add up to 180. So that angle here is 180 take away 40 take away 25, which is 115. And now that I know this angle here, which is 45, this angle here, which is 115, I can work out that this angle here is 20, because angles in a triangle add up to 180. So that gives me all the angles which I'm going to need at some point in this question. So back to the question. Find the angle BAL. Well, that's obviously the 25 and the 20, which is 45 degrees. Now, hence or otherwise calculate the distance BL. Now, we're going to be looking at this triangle ABL. We know all the angles. If we're going to be able to use the sine rule, we need to know one side to start with. Now, we can work out the length AB because we're told that it takes us 30 minutes, which is half an hour, to travel the 14 knots, the 14 nautical miles, the 14 miles. So if we're going 14 knots in an hour, we're going to go 7 knots, 7 nautical miles in half an hour and 30 minutes. So we know this length here is 7. Now we can use the sine rule. We can say that BL over sin 45, so that length over its opposite angle equals 7 over its opposite angle of 20, so 7 over sin 20. Now remember, always put the unknown on top, so as we're working out a side, use the sine rule with the sides on top. This minimizes the amount of rearranging. Just to make BL the subject, we just need to undo the dividing by sin 45, so we multiply by sin 45, pop that into a calculator, and round as you see fit. I've done it to 1 decimal place, so 14.5 nautical miles.